Hi folks, I'm Mr. V, and today's lesson does not come from illustrative mathematics, but it is an extension that I've added which deals with problem practice and parallelisms or parallel lines. And before we begin, I'd like to point out to you that at the end of the lesson, the goal is to say I can use what I know about angles and parallel lines to solve problems. I'd like to present to you this idea that I have come up with, and this is one that will help you with solving problems for just about every mathematical problem that you will encounter as a high school student. And it's called idea. If you do these 4 steps, and this is pretty well thought out, that it will help you to come up with good answers to what are usually problems encountered by high school students. First one is to identify the relationship. So in mathematics, is what is given and what is it you're asked to find. How do the two relate? Here in my picture, it's which one is the predator and which one is the prey. The second step is to devise a plan, and a plan of attack if you want to. In mathematics, this means coming up with an equation that expresses the relationship that you found in the first part. Third thing is to execute the plan, or solve for x, solve the equation for whatever is missing. And then the last thing is to answer the question that was asked. In math, it looks the same. Sometimes you're asked to solve for x, and sometimes you're asked to substitute the x value that you find, or whatever missing variable you find, back into an equation, or use it some other way. So that's the one thing. The other thing I'd like to, so here's the summary of this idea as a problem-solving strategy. What I'd also like to point out is that when we do problems, they're different from exercises. If I ask you what is 2 squared, you say that's 4. Well, what is 5,280 squared? I don't know, but I know the procedure of how to do it. That is an exercise. A problem requires you to think. Sometimes you have to think longer than 2 seconds, click, click, and be done. You have to think maybe a minute, or maybe half a minute, or maybe 5 minutes. Some math problems have been outstanding for over 100 years. People have been thinking of them and trying to solve them. One was just recently solved in 2000. That was an ancient 300-year-old problem. So these problems that I'm going to give you today, some of them are not trivial. Some of them will be problems to you. My idea is to turn them into exercises. In other words, make it to where it's so routine that you understand it. But a lot of them involve mathematics in a way that maybe you haven't used with this illustrative mathematics curriculum. So the first thing we do is we mark on this drawing all of our angle measurements, and we know that angles that are next to each other, like these, this one and this one, are a linear pair, so this would have to be 63 degrees. They have to add to 180. And all of these angles are the same. These are vertical pair. These are corresponding with this one, corresponding. And these other angles are also the same as 172. They look obtuse, but they are obtuse because these lines are parallel. And knowing their relationship is one thing, but being able to use it is quite another. So here we have a transversal is a line that crosses 2 or more lines. It's a fancy word for saying a line that crosses 2 or more lines. When those lines that it crosses are parallel, it creates a special relationship. And the names of those, there are names for most of those relationships, not all of them, but most of them. And when you first learn about parallel lines, the relationship itself is what's more important. But there comes a time when the names are important as well. And this little next exercise is a sorting exercise where you actually use the names. So if you start with the transversal and the angles that you're looking at are on either side of the transversal, we call those alternate. If they're on the same side, we call them same side, unless they are corresponding. If they're corresponding, that is, it's in the upper right-hand corner of where the transversal is crossing each of those parallel lines, that would be corresponding. Also, if the 2 angles fall in between the parallel lines, those would be interior. If they're on the outside of where those parallel lines are, those are exterior. And corresponding will have one that's interior and one that's exterior. So here's a sort. If I were you, I would put the categories up at the top, I would associate the pictures with it, like a vertical pair. This is a vertical pair. Non-adjacent angles formed by intersecting lines. When you get them all correct, you get a no. And you also have a thing here showing you how far along you are, how many cards that you have correct. This is a graphic organizer that I've prepared. It shows not only the names of the relationships, corresponding, alternate, interior, alternate, exterior, vertical pair, but it shows the actual relationship. So these are congruent. Their measures are equal. And these are supplementary. Their measures sum to 180. And these are complementary. Their measures sum to 90. And when we're dealing with parallel lines, that's usually the relationship. It's either they're equal, they are sum to 180, or they sum to 90. So here we have a short exercise. This is to graph these points. And when I do that, I have -6, -4, which would be right here. I have -1, -1 here. I'm sorry, 1, -1. That is not right. 1, -1. 0, -4, and -7, -7. When I connect these with my lines, I get a parallelogram. And the idea is to explain why this is a parallelogram. And it's not enough to say, oh, well, they look parallel, or the sides look parallel, or to say, well, they're parallel because they don't intersect. That's circular logic, using what you're trying to prove as part of your argument. You can't do that. And so what I'm going to draw on here is something that you might be familiar with. Maybe you've seen this before. I should do this in a different color. This is called a slope triangle. The slope here, there's a rise of 3, the run of 1. The slope is equal to 3/1. And over here, we have the same thing, a slope triangle. We have a rise of 3, a run of 1. They have the same slope. Because lines that have the same slope are parallel, we know that, 3/1. We know that these lines are parallel. And we can do the same thing with the other two lines, drawing a slope triangle for them. There's a video here on auxiliary lines, and auxiliary lines, you can draw a line that's parallel to an existing line, you can extend a line, it's a line segment, and you can draw a line that's perpendicular to a given line through a given point. So there's different ways of solving problems. And here I've got some basic problems, basic level 1, 2, 3, and 4. I'll show you a couple of these, and then you can check your answers. If your answers are not correct, you need to figure out where you messed up. Starting with this first one. One way to solve it would be to draw an auxiliary line that goes through this intersection. And I'm going to draw it parallel. So I'm making this line parallel to the existing lines. That's one thing I can do. And using this information, if this is 130, this is a straight angle. So this angle here would have to be 50 degrees. And means that this angle, which is an alternate interior, is also 50 degrees. The most common incorrect answer is to say that x is 50. But notice these two angles have to sum to 90 degrees. It's the right angle. So this would have to be 40 degrees. And since these two angles are alternate interior, x is equal to 40. A different way of doing this problem, which you will use on some of the other ones that I'm not going to demonstrate for you, would be to extend a line. So if I were to extend this line, again, I know that this is 130, and over here we have 50 degrees, because it makes a straight angle. Alternate interior angles formed by a transversal, causing parallel lines, are congruent, so this is 50. Since this is a 50, 90, and x degrees, the three angles have to add to 180, so x is equal to 40 degrees. A third way of doing the same problem would be to draw a line that's perpendicular to a given line. So I'll draw a line that's perpendicular that goes through this point. So this is a right angle, this is a right angle. Here we have 130, this is 50, the third angle of the triangle would be 40. With a straight angle, so this would be 50. Here we have a triangle through three angles, so x is equal to 40. Do you see how this is done? The fourth one of these is one that looks like this. And to solve for x, yes, you could draw a parallel line here, but you will probably have to draw one here as well, and follow it all the way over, and follow it all the way over to get to x. In the Desmos, If it's known that alternate interior angles are congruent, what can be said about the other pair of alternate interior angles? What about alternate exterior angles? What about any pair of corresponding angles? So here are problems that are a little bit more difficult, and I'm very interested in your explanation. So it's not just a matter of solving the problem. And the answers are shown. If I go over a couple of pages, here's the answers. But I need you to actually explain your reasoning when you do these problems. And I will show you how I would mark the drawing for some of these. Let's see if I can do this one. Copy it over to my whiteboard. And I have, if I were to look at same side interior angles, they have to be supplementary. This angle plus this angle have to equal to 180 because they're formed by transversal crossing parallel lines. So W would equal to 108 degrees. Then if I bring this down and I were to draw a line parallel to the existing one, parallel to this one, if this is 108, this angle here would be opposite, same as this opposite angle, this would be 72 degrees. So 72, to be 98, this extra piece down here would have to be 22 degrees. So, I'm sorry, 26 degrees. So this angle is 26 degrees. In our next angle, I'm going to point out to you what may seem relatively simple without drawing any extra pieces. Here I have alternate interior angles. If I were to extend this line, I could extend this one. Extend this one. Can you see the transversal crossing the parallel lines? So this angle is 3x. These two angles are supplementary. How would you find x? And finally, for this one, I'm going to extend both of these lines. I can extend this one. I'll also extend this one. When I do that, these are corresponding angles. The three angles have to add to how much? How could you solve for x? And you see how an auxiliary line will help us. Now, if you recall that a quadrilateral has two pairs of parallel lines, draw the parallelogram, mark the drawing. When you draw it, you're going to draw lines that are parallel. I'll draw them like this, I'll draw them right apart. Notice this does not have any reflective symmetry. Only a rectangle, rhombus, or square would have reflective symmetry. This has rotational symmetry, but it says I'm supposed to mark the drawings. To be a parallelogram, both pair of opposite sides have to be parallel, so we'll mark these as parallel, I'll mark these as parallel. Now I've got a parallelogram. What can be said about the angles? Well, the opposite angles would have to be congruent. The adjacent angles would have to be supplementary. These have to add to 180, these two are congruent. Next, we have some challenging problems. And I don't know if I'm going to go through all of these. I think I might show you a couple of things with this. But really what I want you to do is to try to figure this out on your own. So I'm going to maybe get you started on something. Show you some markings that I might make if I were doing this. So if I have 2x, this angle, and I were to extend this line, I would have this angle for be 2x. This is one way of doing this problem. From there, you should be able to solve it. Here we have something that is, when you go through these, you should really try to solve them on your own before looking at my hints or what I'm doing. This one, we might need to know something about triangles to do this. So if I extend this line, I know that the opposite angles in a parallelogram are the same. This is 2x. I also know that if this is, let's see, 2x, an exterior angle of a triangle is equal to the sum. So if this is 2x, this is x. 2x plus this must be 180. And this angle plus this one have to be 180. So this angle must be x, because an exterior angle is equal to the sum of its remote interior angles. Can you see why this makes a straight angle 180? And these three angles equal to 180, so this has to be equal to x. From here, you should be able to solve for x. Let's see, the next one of these problems is a little bit more difficult. There are several ways of solving this problem. I'm going to show you one hint for this. If I were doing this, I'm looking for x, but I don't know what this angle is, so we'll call it y. Three angles of a triangle sum to 180. This one is 40 degrees. Now, I know that these three angles add to 180, and I know that these three angles add to 180. Last of all is this problem, and I'm going to copy it to my whiteboard and show it to you. So this is going to be the same because this is an isosceles triangle, because this is a circle and the radii of a circle. So the base angles would have to be removed. These three angles would have to be the same. If you called them y, and you use your knowledge of a transversal crossing parallel lines, so this angle and this angle, what do you know about these two angles? Because this is the transversal crossing parallel lines. You should be able to solve for y, and from there you should be able to solve for x. Now, I have posted the answers. Please check them out. If you don't get them correct, then try to get them correct. Here we have supposed to mark these 2 points on the grid, and then do a graph. There's a video of this here, and also what can you say about the lines. And finally, we have this business of this equation. So the slope, the line that is perpendicular, is going to be the opposite reciprocal. This would have a slope of negative 1/5. And if you read about or learn about the point-slope form of an equation of a line, so my slope of my perpendicular line will equal to negative 1/5 because it's the opposite reciprocal slope of this. This is in slope-intercept form, y equals mx plus b. Point-slope form of an equation of a line is y minus y sub 1 is equal to the slope times x minus x sub 1. We know x sub 1, y sub 1. We can substitute this into the equation. Y minus negative y minus 5 is equal to negative 1/5 times x minus a negative 2. And this is my equation, my line. And that's all I've got for you today. So good luck and success.